Welcome to Aircraft Electrical Fundamentals, DC Motor. What is a generator? A generator is an electrical machine that converts kinetic energy into electrical energy through the process of electromagnetic induction. The working principles of a modern-day generator follow Faraday's law of electromagnetic induction. This principle states that whenever a conductor cuts the magnetic fluxes, a charge is induced in the conductor. Using Fleming's right-hand rule, the direction of the induced current changes with the movement of the conductor, enabling us to determine if the generator is AC or DC. The characteristics of a DC series motor are dependent on three curves: torque vs armature, speed vs torque. The working principle of a DC motor is an electrical machine that converts electrical energy to mechanical energy through the interaction of two magnetic fields. A DC motor requires a source of power to excite both the stationary winding and rotating armature winding. In a DC series motor, the field is connected in series with the armature. It is then wound with a large wire a few times due to its ability to carry a full armature current. This causes the motor to develop a large amount of starting torque. There are 5 types of DC motors. Separately excited, self-excited series, self-excited shunt, self-excited compound. However, DC series motors cannot be used in applications where constant speed is needed under varying loads. Permanent magnet DC motor. Working principles of a permanent magnet DC motor is similar to that of a DC motor. The armature is placed inside the magnetic field of the permanent magnet and rotates in the direction of the generated force. The advantages are no need for field excitation, cheaper and more economically friendly for appliances, and no field coil needed, helping to cut down the overall size. Applications will be automobile starters, toys, air conditioners, computer disk drives, and washers. A separately excited motor is a motor where the main supply is directed to the field and the armature windings. The main difference between this and DC motor and those mentioned above is the fact that the current flowing through the armature does not pass through the field windings. This is because the field winding is energized by a separate external source of DC currents. For a self-excited DC motor, the field windings are connected in either series or parallel, or being half series or half parallel to the armature windings. There are 3 classifications: shunt DC, series DC, and compound DC. For a shunt-wound self-exciting DC motor, the field windings are exposed, enabling it to experience the full terminal voltage, due to it being connected in parallel to the armature windings. A shunt-wound DC motor does not vary in speed with relation to the variation in mechanical load output, thus it can be called a constant speed motor. For a series DC motor, as the armature windings are connected in series, the full armature current will flow through the field windings. For a compound DC motor, its excitation characteristics can be obtained by combining both the operational characteristics of the shunt and series excited DC motors. The compound DC motor has its field windings connected in both series and parallel to the armature. A cumulative compound DC motor is produced when the shunt field is assisting the main field flux when its main field is connected in series to the armature windings. A differential compound DC motor is produced by arranging the shunt and series windings in such a way that the field flux produced by the shunt windings helps to remove any effects of the flux. If the shunt field winding of the short shunt is parallel to the armature winding and not in series arrangement, then it is called short shunt. If the shunt field winding is parallel to both the armature windings and the field series arrangement, it is known as a long shunt.
Created using Powtoon.